Your eyes are the greatest trick evolution ever played on you. In 1901, a fossil was unearthed in Egypt that made the scientific community collectively lose their minds. 3 tons, with 2 terrifying giant horns on its head. Top paleontologists worldwide said in unison, "This is a prehistoric rhinoceros." Then a century later, DNA proved them dead wrong. It has nothing to do with rhinos. Its real relatives are elephants, manatees, and the tiny hyrax you could hold in your palm. Evolution can make 2 completely unrelated species develop identical bodies. This is called convergent evolution. Nature's most insidious lie. What's really chilling is, if top scientists were fooled for an entire century, what makes you so sure that anything you see in your life is real? This monster is called Arsinotherium. The origin of its name is even more absurd. It was named after the ancient Egyptian queen Arsinoe II. Why? Because the first fossil was dug up right next to the ruins of her palace. An ancient beast from 30 million years ago and a human queen from over 2,000 years ago, bound together by fate like that. The man who discovered it was named Peter Neal. He was a British geologist. That afternoon in 1901, when his shovel hit that fossil, he had no idea he was about to uncover a century-long scientific puzzle. The first time he saw it, he was completely stunned. This thing had the horns of a rhino, the legs of an elephant, and the lifestyle of a hippo, but it wasn't related to any of these 3 animals. The fossil was carefully shipped back to Europe, presented to the world's top paleontologists. Everyone shook their heads after looking at it. What on earth is this thing? Scientists argued for decades. Some said it was the ancestor of rhinos. Some said it was a distant relative of elephants, and others said it was just a mishmash. Back then, there was no DNA technology. All they could do was guess from bones. And this creature's bones were like a multiple-choice question nature deliberately set. Every option looked correct, but none of them was the right answer. Look at those 2 horns, protruding forward from above the nose, just like a rhino. Then look at its size. Shoulder height of 1.75 meters, body length of 3 meters, weight close to 2.5 tons, almost as large as a modern white rhino. The first thing any normal person would think when seeing this, isn't this a rhinoceros? But here's the issue. If you take out its leg bones and look closely, you'll find a strange fact. Its legs are straight, like pillars. These aren't a rhinoceros's legs. These are an elephant's legs. A rhinoceros's legs are bent, suitable for fast running and violent charging. But the heavy-footed beast's legs are designed to support weight, not for fighting. What's even stranger is yet to come. Scientists took out its hip bone and looked at it. Wow! This too is the elephant type. Wide and stable, suitable for slow movement. Completely unlike the rhinoceros type, which is designed for sprinting. In other words, this thing has a rhinoceros's face, but is built with an elephant's body. It's as if someone forcibly stitched 2 completely different animals together. But what truly broke the scientists was that pair of terrifying giant horns. On the surface, these horns seemed perfect for fighting. Big and sharp, jutting forward. They were practically natural weapons. Early reconstruction drawings all showed it that way. A heavy-footed beast, lowering its head, charging at an enemy like a tank, using those giant horns to knock the opponent to the ground. Skeletons in museums were also arranged that way, with the horns placed in the most prominent position, suggesting it was a fierce fighter. For decades, countless people believed this story, until one day, a scientist had a sudden idea to cut open these horns and see what's inside. That single cut left the entire paleontology world fell silent. The horns are hollow. Inside they aren't solid bone, but are full of blood vessel grooves and honeycomb-like structures. What does this mean? It means these terrifyingly fierce giant horns simply couldn't withstand a violent collision. If the heavy-footed beast had really used its horns to charge like a rhinoceros, it might have broken on the very first hit. This thing is a paper tiger. A rhinoceros's horn is pure keratin, as hard as compressed hair. Cattle and sheep horns have a solid bone core, wrapped in keratin, and can withstand repeated impacts. But the heavy-footed beast's horn falls somewhere in between, yet isn't as solid as either one. Its bone core is hollow, and it might have been covered by a layer of keratin sheath, making it look bigger and more frightening. But essentially this was a prop to scare other animals, not a weapon for real fighting. So what exactly are those horns for? Scientists studied the connection between its skull and neck. They found an interesting detail. Its neck muscles were extremely developed. There were strong muscle attachment points on the back of its skull. These could control the head for powerful swinging. But this power wasn't wasn't used for ramming. It was used for slow, ritualistic pushing. What does that mean? When two male heavy horns competed for a mate, they wouldn't charge at each other like rhinos. Instead, they would lock horns and slowly push against each other. This was more like a wrestling match than a bloody duel. The loser would slowly back away and then slink off in embarrassment. The whole process could last several minutes, but neither side would end up seriously injured. This is the wisdom of evolution. Determine the strongest individual at the smallest cost. But the heavy horn's deception wasn't over yet. Many people thought, such a large animal must have spent all its time in water, like a hippopotamus. After all, it couldn't run, and its legs were so thick. Staying in the water was safest. Early reconstructions were drawn that way too. The heavy horn half submerged in a swamp, with only its nose and those terrifying feet exposed, like two periscopes, appearing and disappearing on the water's surface. This image was indeed striking, but it was also wrong. Scientists conducted isotope analysis on the fossilized teeth of the heavy horn. What are isotopes? Simply put, they're the ID cards of atoms. They can tell you what this animal ate when it was alive, what it drank, what kind of environment it lived in. The results showed the heavy horn was not an aquatic animal. It spent most of its time on land. It might go into the water to cool off when it was hot, but it primarily lived on the shore, eating terrestrial plants. So why couldn't it run? The answer is simple. It didn't need to run. 30 million years ago, Egypt's Fayum region wasn't today's desert. It was a tropical rainforest and mangrove swamp. It was an animal paradise. Primitive monkeys leaped through the treetops. Early whales cruised through nearby seas. Giant crocodiles lurked in the water, waiting for prey. Primitive elephant relatives wandered slowly through the forest. And at the top of this ecosystem stood the heavy horn. It didn't need to run. It didn't need to hide. There's no need to worry about anything. Food is everywhere there. No natural enemy can threaten a 2.5-ton giant. It doesn't need to run at all. It just needs to stroll along slowly, eating everything edible that's in its way. Speed is not a necessity for survival. Size is. The teeth of the Barolambda are also interesting. It has a complete set of 44 teeth. This is a very primitive configuration among mammals, but these teeth are not used for chewing grass. They are used for cutting soft leaves. The attachment points of its jaw muscles suggest its chewing style is more like that of a cocoon, rather than a beast. This means it's a picky eater, preferring tender leaves and fruits, soft things like aquatic plants. It doesn't eat grass. Remember this, because this will become the key to its extinction. Barolambda lived from the late Eocene to the early Oligocene, about 36 to 27 million years ago. At that time, the Earth was undergoing a huge transformation, from a hot and humid greenhouse Earth, gradually transforming into today's icehouse Earth, with distinct hot and cold periods. This process sounds slow, but it was fatal to many species. 27 million years ago, the Earth entered a colder, drier phase. Tropical rainforests in northern Africa began to shrink, replaced by vast grasslands. Grass, a plant that seems more ordinary than ordinary, became the death knell for Barolambda. Why? Because the leaves of grass contain large amounts of silicon dioxide, which is the main component of glass. Eating grass is like chewing glass shards. It would quickly wear down its teeth. To eat grass, you need specialized molars that can continuously grow to counteract the wear. Horses have such teeth. Cattle and sheep do too. But Barolambda does not. Its 44 primitive teeth are used for cutting tender leaves. Faced with the grassland's rule, it has no defense against grass. Its teeth will be worn down, then it starves to death. Ironically, its close relative, the elephant, survived. Elephants also belong to the Proboscidean group and share a common ancestor with Barolambda. But elephants' teeth are more adaptable, able to eat both leaves and grass, and even tree bark. When the environment changed, elephants adjusted their diet, expanding their range. They eventually spread across all of Africa and Asia. As for the amblypods, they locked themselves into a narrow ecological niche. Their stomachs only ate soft leaves. They only stayed near swamps, and they only relied on their size to scare off enemies. When the swamps disappeared, and soft leaves were replaced by grass, they had no way out. Evolution does not reward the strongest. Evolution rewards the most adaptable. The amblypods lost. More cruelly, their size went from an advantage to a burden in the survival contest. A 3-ton body needs a huge amount of food and water every day. In the tropical rainforest, that was no problem. But on the dry grasslands, food is scattered, and water sources are scarce. A giant beast simply couldn't find enough supplies. It was too large to move quickly. It was too heavy to travel long distances. Those that could survive in the new environment were instead smaller, more agile, and more omnivorous animals. The amblypods were trapped by their own success. By the middle of the Oligocene, about 27 million years ago, the amblypods had completely disappeared from the Earth. Not killed by predators, not wiped out by disease, but destroyed by their own picky eating habits and over-specialization. Imagine that scene. The last amblypod stood by a dry riverbed, surrounded by endless grasslands. Nothing it could see was anything it could eat. Those huge horns glittered in the sunlight. But what use were big horns? It couldn't use its horns to digest grass, nor its feet to find water. It could only walk, step by step, slower and slower, weaker and weaker, until it fell and could never get up again. Its terrifying giant feet, its massive body, its seemingly invincible appearance, were worthless in the face of climate change. But the story isn't over yet. The greatest legacy the amblypods left us isn't that one shocking saying, but a profound lesson about convergent evolution. What is convergent evolution? It's when two species with no genetic relation at all, because they live in similar environments, faced with similar survival pressures, they ultimately evolved similar body structures. The toxodont looks like a rhinoceros, but it is not a rhinoceros. Rhinoceroses belong to Perissodactyla, and are relatives of horses and tapirs. Toxodonts belong to Litopterna, and are relatives of elephants, manatees and hyraxes. Their common ancestor diverged tens of millions of years ago, but they eventually ended up with almost identical appearances. What does this tell us? It tells us that what we see with our eyes is not necessarily true. Looking alike doesn't mean they're family. Similar appearance doesn't mean the same inner core. Nature can create identical-looking products from completely different materials. Scientists were fooled for a century because they trusted their eyes too much. When the last Macrauchenia died, there was no longer any animal on Earth with that iconic pair of horns. An evolutionary experiment came to an end. Today, if you go to the Natural History Museum in London or Paris, you can still see the skeleton restoration of the Macrauchenia. That pair of giant horns still point forward, as if ready to fight at any moment. But now you know the truth. This is not a warrior. This is a deceiver. Those horns were for showing off, not for fighting. That massive body was for slow walking, not for charging. That mouth was for being picky about food, not for survival. Everything about him was tailor-made for a world that had already disappeared. When that world disappeared, he disappeared along with it. This is the story of the Macrauchenia, a carefully crafted deception by nature, a giant abandoned by the times, a living textbook that tells us with its life, adaptation is more important than strength, more important than success. It existed for nearly 10 million years, ruling the swamps and rainforests of northern Africa. Then, amid the waves of climate change, it vanished silently. No disaster, no natural enemies, no disease. The world just changed, and it did not. Next time you think you are strong enough, successful enough, think of Macrauchenia, 3 tons heavy, 2 meters tall, muscular all over, with horns on its head. Extinct just the same. Evolution doesn't care how strong you are, only whether you can change. The species alive today are not the strongest, but the ones that best adapt to change. Perhaps that is the most important legacy Professor Zhang left us.